All right, welcome. This is 10.2, more derivatives, but this time of exponential and logarithmic functions. Check out my new glasses. They block the harmful blue light from my monitor since we'll be staring at screens till I don't know when. And my eyes feel good today. All right, so let's get started with the derivative of e to the x. And this one's great because the derivative of e to the x is, guess what? E to the x. Oh my goodness, right? So the derivative of e to the x is e to the x, nothing else to it. If you want to see a proof, sure, ask me in class. It's a fun proof. Okay, and then there is another derivative of x to the e, which is definitely a lot different than e to the x, right? This one's x to the e, so we treat it as a normal derivative by the power rule. So the derivative of x to the e is that e comes down, and you get e times x to the e minus 1. That's it. So just note the difference between these two. Here on the left, x is an exponent. Here on the right, e is an exponent. All right. So with that being said, let's go ahead and get started. All right. Open. Okay. All right. Number one, all we want to do is find the derivatives. That's it. Nothing more. Just find the derivatives. So we're going to say f prime of x, and the derivative of 5e to the x is, guess what? 5e to the x minus the derivative of 3x to the fourth. That 4 comes down, multiplies the 3, 12x cubed. Derivative of 9x is just 9. There it is. Done. Because the derivative of 16 is 0. All right. Keep going. Two. Find the derivative. The derivative of negative 7x to the e. All right. So that e will come down, multiply the 7. So you'll have negative 7e times x to the e minus 1. All right. And then the derivative of 2e to the x is just that, 2e to the x. And the derivative of e squared. Now this one's tricky because it's not e to the x and it's not x to the e. E squared is just a number. This is just a constant, which means the derivative of e to the second is just 0. So that's it. We're done again. Okay, not bad, right? Maybe too easy. Calculus, way too easy, right? Once you learn the shortcuts, of course. Yeah. Third one, f prime of x, the derivative of 9e to the x is 9e to the x. Plus derivative of 2x squared, 4x. That's it. Not bad. All right. Last one for these ones. F prime of x, derivative of 3x to the e. Once again, this one, the e comes down, and you get 3e times x to the e minus 1. minus the derivative of 2e to the x, 2e to the x. That's it. And that is the derivative of these exponential functions, e to the x and x to the e. Okay. Now on to logs. All right. So next is the derivative of the natural log of x. The derivative of the natural log of x is 1 over x. And it has to be in this form. If we get something else inside the natural log, then we have to use the log properties, which I wrote below, to simplify it and then take the derivative. So remember these 3 log properties from your last class? These are the 3 main log properties that will stick with you forever. First is the product to sum. If you have the product of 2 terms inside your logarithm, then you can separate them by addition. So the natural log of x times y is the same as the natural log of x plus the natural log of y. So this was, what did I say? Product to sum. Next one is the quotient to difference. The natural log of x over y can be split into the natural log of x minus the natural log of y. So this is the quotient to difference. And then last is just the power rule for logs. Now, do not get this confused with the derivative. A bunch of students get it confused with the derivative because it has a similar method, right? Remember with the derivative, the power comes down to the front, but with the derivative, you have to take one away. With log properties, this n comes to the front and rewrites it as n times the natural log of x. And what you must make sure of is that no derivative has been taken, because if we do the derivative, you subtract the 1. Is there a subtract 1 in any of this? No. All we did was take that power, move it down in front of the log. That's it. No derivative. So this is just the power rule. Okay. Not to be confused with the derivative power rule. All right. So next, let's find the derivatives of these logarithmic functions, and we start with f of x equals the natural log of x squared. Remember, in order to find the derivative of the natural log, it has to be natural log of x by itself. It can't be anything else inside those parentheses, which means if there's something else there, we must simplify by log properties. Just like here in number 1, there's a 2 here. We can't take the derivative until we get rid of this 2, which means we're going to use the power rule for logs. So first is I rewrite this as the 2 comes down, 2 times the natural log of x. And remember, we have not taken the derivative yet. But now, it is in the perfect form to take the derivative of, because now we have that natural log of x. We have this x all by itself, and that's what we need. So this means that f prime of x, the 2 stays there, and the derivative of the natural log of x from above is 1 over x. Multiply the 2 in, and you get 2 over x. That's it. Nothing else. All right. 2, the natural log of 4 over x cubed. Once again, we only know how to take the derivative of the natural log of x. So we have to make this look like that somehow. And the only way to do that is, again, by log properties. So what we notice is that this is a quotient, so we will use the quotient to difference property for logs, which means this becomes the natural log of 4 minus the natural log of x cubed. Once again, we have not done any derivatives yet. We are just simplifying algebraically by log properties. Okay, the natural log of 4 is good, but the natural log of x cubed is not. We want the natural log of x, which means we have to get rid of that 3. And to do that, we once again use the power rule for logarithms. So this eventually becomes natural log 4 minus 3 natural log x. And we are ready to go. We can find the derivative now, right? We can find the derivative. So f prime of x, guess what the derivative of the natural log of 4 is? Once again, this is a constant, because the natural log of 4 is a number. It's a decimal number. And any number without a variable is a constant. And the derivative of all constants is 0. Minus 3 times the derivative of the natural log of x, which is 1 over x. And our final answer is just negative 3 over x. All right. Nice, nice. And keep going. 3. No rearranging needs to be done at all. There's the natural log of x, which means it's in the perfect form, so we can take the derivative. That 6 stays out front. Derivative of the natural log of x, 1 over x, minus derivative of x cubed, 3x squared, derivative of 2, 0. Clean it up. 6 over x minus 3x squared. All right, not bad. Number 4. F prime of x, the derivative, and once again, no rearranging needed. The natural log of x is in the perfect form to take the derivative of, which becomes 1 over x, plus derivative of 2 e to the x is just as it is. 2 e to the x, minus the derivative of 3x squared is 6x. There you go. I mean, I guess I don't need to box the whole thing, just like we did. There you go. And there's your derivatives. So those are derivatives of natural logs and e to the x, an exponential function. E to the x and x to the e. All right. Next is, of course, finding a tangent line, which we love to do, right? So remember, to find the equation of a tangent line, you need two things. You need a slope and you need a point. Well, remember that if we find the derivative, we find the slope of the tangent line. So let's go ahead and actually, we'll find the point first, and then we'll find the derivative. Because the first thing we need is definitely a point, and all they give us is an x value right now. So remember that our point is always xy. And right now they're giving us 1 for x, which means we need to solve for y. So to find y, just take this x value of 1 and plug it into the original function to get our y value. That's what we're going to do. So you'll get f of 1 is equal to 2 times the natural log of 1. And if anybody remembers, the natural log of 1 is always, I'll wait, I'll pretend like I'm hearing you, waiting for the answer. The natural log of 1 is always 0. That's right, you got it, right? Okay, so 0, which means that our point is now 1, 0. Okay, now we have our point. All we need is our slope. Which means take the derivative of the function above. So f prime of x is going to be equal to the derivative of 2 natural log of x, which will give me 2 times 1 over x, or 2 over x. Okay, but we want a slope, so we need a value to plug in for that x value, for that x variable. Did they give us an x value in the very beginning? Yeah. They said x is 1. So what we're gonna do is take 1 and plug it in for that x. That's it. So we'll say f prime at 1 gives me 2 over 1, which gives me 2. This is the slope of the tangent line. This is m tangent. All right, so we have the two ingredients. We have our point, we have our slope. Let's find the equation of the line. And of course, I wrote too big. All right, I can fix it over here. All right. The tangent line, and we know that we can use this formula, y minus y1 equals m times x minus x1. And my y1 and x1 value is 1, 0. So I'll get y minus 0 equal to my slope, which is 2, times x minus 1. I'll get y equals 2x minus 2, and there it is. There's the tangent line. Using everything, all the information we got from the left side. So a point and a slope. 1, 0, and 2 is your tangent. Okay. Now, let's do it again for e to the x. First thing is, let's find the point. They give us that x is 0. So we have 0. And we need to find y, which means take 0 and plug it into the original function to get our y value. So f of 0 equals e to the 0 plus 1. And here we go again, like I'm talking to people that aren't here. Anything raised to the 0th power is always one. If you said 0, leave now. So anything to the 0th power is 1, and you get 1 plus 1, which will give us 2. Which means our point is now 0, 2. All right, next is slope, which means take the derivative. F prime of x, derivative of e to the x is e to the x. Derivative of 1 is 0. Hey, there we go. So the derivative is e to the x, which means to find the slope of the tangent line, you take 0 and plug it into that x. There and there, right? So we get f prime of 0, which gives me e to the 0th, which is, again, anything to the 0th power, we get 1. And this is the slope of the tangent line. Okay. All we need left is the equation, the tangent line. Y minus y1 equals m times x minus x1. Plug in our point above, 0, 2. So y minus 2 equals my slope of 1 times x minus 0. And everything's in the right place. Yes. And solve for y. So you'll get y minus 2 equals 1x, and y equals x plus 2. There it is. There's our tangent line. Hey, that wasn't so bad, right? Okay. All right. Last derivative of another exponential function. So we know the derivative of e to the x is e to the x, but let's say the base is anything other than e. Then the derivative of an exponential function with base a raised to the x is going to be given as the same thing, a to the x times the natural log of base a. So if it was 5 to the x, then the derivative would be 5 to the x times the natural log, and it's the natural log of whatever the base is. So it'd be natural log of 5. That's it. Nothing crazy. Which means we could try it below. Purple. All right. So find g prime of x for 2 to the x minus 3 to the x. So this is g of x. I'll just put that there. So when we say g prime of x, the derivative of 2 to the x, using this formula up here, is going to be the same thing, 2 to the x times the natural log of the base. All right, minus, do it again, the derivative of 3 to the x using the same formula. 3 to the x times the natural log of base 3. And that's it. We can't do anything else. That's as pretty or as ugly as it's going to get. Ooh, not bad, right? Follow the formula, you'll be okay. I guess it's a formula now, right? All right. Last example, word problem, right? So the estimated salvage value S in dollars of a company airplane after T years is given by the function S of T equals 300,000 times 0.9 to the T. What is the rate of depreciation in dollars per year after 1 year, 5 years, 10 years? Okay, so what we have to do here is find the derivative and plug in 1, 5, and 10. And if you're asking, why do we have to find the derivative? Well, there's a very special word in this whole problem, and that word is rate. Rate of change, slope, instantaneous rate of change, all mean to take the derivative, right? We got rate of depreciation. We want to know what is the rate or what is the slope decreasing at, which means, hey, find the derivative. Okay, so we find the derivative, right? So we'll say, I'll zoom in. I got a bunch of room, I think, but I'll say find S prime of T. So we want the derivative of this function. Okay, so looking at this function, we only need the derivative of this part, the 0.9 to the T. This is just like we learned above. This is the same as the derivative of a to the x. So when we set this up, you're going to have S prime of T equal to, and the 300,000 stays there. And I'll put a bracket to be neat. And now let's take the derivative of the exponential function 0.9 to the T. And using the formula from above, remember that it's a to the x times the natural log of a. We're going to get the exact same function back. (0.9 to the T) times the natural log of the base that's there already, 0.9. Close the bracket. There it is. Derivative is done. All we have to do now is plug in numbers. 1 year, 5 years, 10 years. So S prime of 1, S prime of 5, and S prime of 10. And calculator time, of course. I shut down my graphing calculator. I could use Desmos. Do I want to do that? No. I'm going to use my graphing calculator. I got to find it first. Loading, loading, loading. Clear table. All right. Let's type this function in. 300,000 And then it's all connected by multiplication. So I'll just have it as it's written. I'll write parentheses, 0.9, close parentheses, raise that to the x, move over, and then write times the natural log of 0.9. There we go. And boom, 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 boom. Type in 1, 5, 10. And we get negative 28,447.34. Negative 18,664.30. And negative 11,000.8. Okay, excellent. Why are these negative? Because the company airplane over the years its value is going to decrease. Hence the words here, rate of depreciation, right? Just like anything, just like your car, anything you own, it's gonna decrease. What is it? Right when you drive your car off the lot, they say it's worth half now. How dare they? But, oh, all right. Oops. Okay. Well, that was more derivatives, including log functions and exponential functions, and it's not too bad, right? So, other than that, it's done. See you at the next one.